Perhaps a snapshot of the beginnings of life on Earth, finger-like forms protruding from damp mud, craters and mounds of every size, the dense air saturated with the peculiar smell of wet vegetation, laboratory gases, salt, and drying algae. This ever-changing landscape is one of stark contrasts. Bright, scorched mudflats to dark, damp creeks. What is this desolate landscape, this lost world? The mangroves, home of the rhizophora tree. This awkward-looking trees live in a dynamic zone full of adventure. Battered by the elements, flushed and fed by the ocean, the earth beneath their stilted legs is constantly on the move. A community of many specialized life forms, these forests emerge in the region where land meets ocean. The interface of these two ecosystems is one of high productivity, with a repository of stories on life, the universe, and everything. Controlled by forces beyond the Earth's atmosphere, mangroves are characterized by the tidal cycle, the repeated flooding and rapid transformation of this habitat by seawater. Tides are the most significant superpower of the moon. They are the predictable, periodic swellings and shrinkings of the ocean, like the breath of our planet. As the moon revolves around our planet, it attracts and pulls the water beneath, causing the tide in that region on Earth to rise. The layout, features, and elevation of the land create paths along which the tide flows in and out of these groves. It is these paths of inundation that classify different types of mangrove forests. A foray into this world can feel like a sensory overload. The oozing sensation of sticky wet mud, the pungent smell of gases escaping from a bed of jelly-like earth that is depleted of oxygen, where decomposition is anaerobic. Pools of still water, stained from the tannin of rotting wood and leaves, and the color of the soggy earth, a clue to the moisture level and decomposition beneath. Stepping into a patch like this might suddenly have you waist deep. The jungle gym-like root system of the rhizophora, an extravagant structure. Large arched stilt roots emerge from elevated trunks, and prop roots descend from their crowns. Rhizophora are very stable and can breathe even when submerged. Another species that inhabits and thrives in this habitat is the Avicennia, identified by its unmistakable bed of pointed roots that radiate around the base of the tree. They stick out of the soil to breathe, functioning like snorkels. The tall Brugueria trees, on the other hand, have bumpy, woody roots protruding like bent knees in less watery spaces. This fancy network of root structures creates something similar to a sieve. Water flowing from land to sea is filtered of all its sediments, ensuring that silt-free water enters the ocean. All breathing roots, be it stilts, knees, pegs, or snorkels, are speckled with tiny bumps. These are lenticels, the breathing pores. Lenticels are clusters of cells that can take oxygen from the air. When the tide comes in, however, these cells swell and seal the pore shut, preventing salty seawater from entering the plant. Although the mangrove trees can tolerate salinity, salt is still detrimental to their growth and well-being. In fact, some trees like the Avicennia have developed specialized salt glands to expel excess salt through their leaves. The undersides of the leaves sparkle with these salt crystals. Fresh water is imperative for survival and growth. In this salty scape, every bit of fresh water must be retained. The waxy coating on the leaves helps reduce the loss of this resource. With the rise and fall of each tide comes life in every size and form. Those who live here possess intricately engineered bodies and abilities in order to survive the ever-changing environment. This unidentified floating object is the seed of the Heritaria, ovoid and woody with an inbuilt sail, a marvelous structure to ensure wide dispersal along waterways and sea-washed banks. The average plant would consider the constant influx of salt water a significant hurdle to reproduction, but these highly adapted trees use it to their advantage. Instead of fruits with seeds, the seeds germinate while attached to the tree. This is called vivipary. This pronounced bean-like structure, the propagule, functions as a float for the young seedling. Perfectly weighted, it bobs along in creeks and channels, keeping the seedling safe and upright until it lodges itself in wet mud and provides a sturdy anchor. Rooted here at this land-sea edge, there isn't a moment of inactivity. Life bustles at every scale. The most abundant creature here is the mangrove creeper. Heaps of snails cluster together to prevent desiccation, feeding on shed leaves. Many crawl along the muddy flats, feeding on other organic matter, and leaving behind maze-like patterns. But some of these shells move a lot faster, leaving behind them tractor-like marks. Pointed legs and animated eyes on stalks emerge. The hermit crabs, comic detritivores, with soft, vulnerable bodies, use any empty shell or shelter as their mobile home. Meanwhile, moving almost in synchrony, white and orange speckles. Could this be a mirage caused by the heat? They are in fact the fiddler crabs, scooping up fistfuls of soil, shoveling it through their mandibles, filtering out rich organic matter, and spitting out balls of sand. The enlarged fiddle-like claw reserved for the males is displayed by waving and used in combat over territory and females. This constant quarreling leads to many broken claws. The fiddler crab will continue to regenerate this enlarged claw, but on the opposite side each time. While the fiddler crabs fight, wave, and vanish with folded eyes into their burrows, the mud skippers scuttle and hop busily in search of food. Supposedly a fish, cousin of the goby, they have colonized both land and water. Mud skippers are funny creatures. Their pectoral fins are elongated and protrude, helping them walk on land. But how exactly do they breathe? Being a true fish, it must be gills. In tide pools and at high tide, they breathe like regular fish. Although, during spells of low tide and while traveling between water bodies, they extract oxygen from seawater stored in a chamber behind their eyes. When the sac of water is depleted of oxygen, this little fish has the ability to re-oxygenate the stored water through its eye sockets with a quick roll of the eyeball. With every rising tide, the nature of the habitat changes once more. The mangroves flood and the fiddler crabs return to their burrows. But in this period of submergence, the barnacles and oysters, cemented on the tree roots, begin to feed. The sheltered waters of the mangroves are now full of juvenile fish, squid, shrimp, rays, and much more. The forest now merges with the sea, and fish venture into this world, in search of food and refuge from predators. When the tide recedes, it takes nutrients out to sea, having deposited those from the ocean into the dense soil of the mangols, and once again begins a feeding frenzy in the mangroves. Waders, raptors, and kingfishers catching trapped fish, monitor lizards scavenging, worms digging, periwinkles scraping. The activity is relentless. As the sun sets on the mangroves, another shift occurs. The chill and darkness of the night brings out other creatures. The dog-faced water snake swims silently or lays motionless, all but its nostrils submerged, on the lookout for suitable prey, like crabs, small fish, and mudskippers. A plethora of nocturnal crabs emerge from their burrows. An elusive mud lobster, hidden in its castle by day, now steps out to forage. Effective diggers, their burrows can reach depths of 3 meters. The mangroves are an extreme habitat in which species have evolved with highly specialized adaptations in order to persist. The habitat never sleeps, and as explorers of this system, every tide brings us new life and adventures